We're going to be looking at algebra today. We're going to be just doing some simple algebraic manipulation. We're going to be looking at collecting like terms, and at some point in another video we'll look at expanding brackets, and then solving some simple linear equations. To begin with, we need to understand what a term is before we can start collecting them. So we need to define a term within algebra. Now a term has a sign, so a positive or negative sign. It has something called a coefficient. Now a coefficient is just a number. It also will have some variables, or one variable, and these are essentially letters for now. Okay. It doesn't always have to have a variable though, it might just be a number and a sign. So here's an example. Plus 3x. So let's check that we have everything in our definition of a term. We have a sign, the positive sign. We have a number, 3, this is the coefficient. And we have the variable x, which is the letter. So we have everything, and this is a term. Okay. Plus 3x really means 3 x's. So plus x plus x plus x, that's 3 x's there. So we've 3 x's could look like plus 3x, or if you write it below, it's just 3 individual x terms added together. Another term, 2 plus 2xy. So again, we have a sign, we have a number, and we have our letters, our variables. Okay, this we could represent as an xy and another xy, because we have two of them, 2 xy's. Plus 4x squared y. We have a sign, we have a coefficient or a number, and we have some letters. These are the variables. Now x squared y, that squared just means that we have x. It's an index, and it keeps track of the variables, keeps track of the letters. So this is telling me that I've got 4xxy. This is keeping a track of the letter that is before. So that 2 says there are 2 x's there. Okay, plus 4xxy means that I've got xxy, 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 and another xxy. I've got 4 xxy's or 4x squared y's. One more, minus 3a cubed b squared. Again, we have a sign, a coefficient, and some letters. Now this could be written as minus 3abb. The 3 there, the index, keeps a track of the a's, and the 2 there keeps a track of the b's. As it's telling me I've got 3 a's multiplied together and 2 b's multiplied together. So minus 3aabb. So I've got a minus aabb, another minus aabb, and a final minus aabb. Okay? So I've got minus 3 of them. So these are all terms. Let's talk about when terms are like. So terms are like if they have the exact same combination of letters or variables. Okay? So terms are like if they have the exact same combination of variables. So, an example. 2p minus 3q plus 4p plus q. So we have some terms. So I'd like you to just write these down and circle each term. So plus 2p is a term. Oh, let's go back. Now that you've circled the terms, let's talk about the like terms. So they're like if they have the exact same combination of variables. So the ones with just a p in are like. So this plus 2p and this plus 4p, they are like terms. This minus 3q and this plus q are also like terms because they have the exact same combination of letters, just q's and p's. So you will notice that this term doesn't have a number. Okay? But in maths we get lazy, and because it's plus q, what we really mean is plus 1q. So there is a number there, we just chose not to write it because we're a bit lazy. This plus 2p at the front, you'll often see it with no sign. Okay, so often it's just written as 2p. There is still a positive sign there, we just choose not to write it again because we're lazy. Okay, so now I'll circle these terms. And what I can do now is I can sort of move these terms around. As long as I keep the signs, keep the numbers, keep the letters together, I can move the terms around. So I could rewrite this plus 2p here, and then next to that plus 2p I could write this plus, well, I'm going to put the minus 3q over here, and next to the plus 2p I could write the plus 4p. Okay. And next to the minus 3q I could write the plus 1q. Okay. Now what I've done is I've put my like terms next to each other so it's easier to see them and easier to add them. So if I have plus 2p and plus 4p, I could add them to become plus 6p. If I have plus 1q's and I take away 3q's, if you think about this on a number line, if you're at plus 1q and you go back 3 places, you'll end up at minus 2q. So combining like terms, I get plus 6p minus 2q. Okay, let's look at another example. So just to summarize that as well, you can add terms only if they are like. Okay? So only if they are like can you add the terms like we've done here. So another slightly more complicated example, 3x minus 2x squared minus x plus 5x squared. So that plus sign there is implied, I didn't write it, and again we have no number next to that minus x, but it's minus 1x really. So let's circle the terms. We have this term, this term, this term, and this term. Now which ones are like? Now a term is like if it has the exact same combination of variables. Here we have the letter x. Where else do we have just the letter x? Here. The other two terms have x squareds. So they're different terms, but the x squareds are like and the x's are like. Now what I can do is I can change positions of my terms as long as I write the whole term. So I could write that plus 3x over here. I could put this minus 2x squared here. Next to the plus 3x I'm going to write my minus 1x. And next to the 2x squared I'm going to write the plus 5x squared. Now I've put like terms next to each other so it's easier to add them. So we can add the like terms. If we have 3x plus 3x and we take away an x, or plus 3x and minus x, we're going to get 2x. Minus x squared plus 5x squared, that will take us to plus 3x squared. So I'll go back to that. So what we've done there is we've added terms that are like. We can't do anything with 2x and minus 3x squared because you can only add terms if they are like. And these two terms have different combinations of variables now, so we cannot add them. Okay, I think we will pause this video here, and in the next video I'll talk about expanding brackets and some other algebraic manipulations.